Okay, so good afternoon, everyone. I hope you're all excited for this session now. I will just quickly introduce myself. I am Anubhi Khandelwal, Digitalized Automation Specialist for Siemens Digital Industries, based here in the UK. I provide pre-sales and post-sales technical support around Siemens virtual commissioning portfolio within UK. So in today's session, we will go through the overview of virtual commissioning portfolio really briefly, and then we will have a deep dive into virtual commissioning for machines. That is one of our offerings for virtual commissioning. We will then have a live demo to show how different software and different products come together to create a digital twin, followed by some useful links and some application examples. And after that, we'll have a brief Q&A session. Okay, so I will begin. The first question always is, what is virtual commissioning and why do we actually need it? Any sort of simulation or virtual commissioning, why is it needed? And the answer to that is these questions. So every now and then, engineers will have questions like, how can I validate my automation program? Or what is the cycle time of my production cell? How can I plan the maintenance of different parts? Or if my electric motor is powerful enough? All these sorts of questions. And the answer to that is simulation and virtual commissioning. So simulation is all about making our designs better, optimizing our processes, and improving performances. And virtual commissioning is a testing in the comfort of your own office or couch or kitchen, whatever you like. Otherwise, you would be doing that under extreme time pressures and possibly standing next to your machine for weeks. Okay, so just to give you an overview of what we mean by virtual commissioning, traditionally, a machine builder would follow this process. So the first stage is concept, which is followed by the mechanical designing and construction, which is then followed by electrical designing, so of all the peripheral electrical devices like drives or motors, which is then followed by writing the automation code. Now, while they were traditionally tested in their own individual silos, there was no way to test them against each other, but that has changed now. So virtual commissioning allows you to work parallelly. It allows to test the code even before the machine is built, so it's possible to minimize errors. We have shorter time to market and ensure its cost savings and quality improvements. So that's the basic idea behind doing virtual commissioning. And what does Siemens do for that? Siemens provide a wide range of software solutions to virtually commissioning our machines or plants or processes, if you like. So what we see here is our virtual commissioning portfolio. We offer a wide range of software solutions that integrate with each other to provide specific application-based solutions. So what we see on the left-hand side is the factory automation side. What we see on the right-hand side is the software simulation side. And when the factory automation comes together with simulation, we have a complete end-to-end virtual commissioning solution. So very briefly, PLCSim Advanced is a virtual 1500 CPU, and I will be going a bit more in detail in a bit. SIMIT is a software that allows the simulation of peripheral electrical devices like drives or valves or push buttons, for instance, or safety simulation. And what we see on the right side are our software from the basic level is AIMISIM, as you see here. It's used to simulate the machine components. So to make sure the motor is of correct specification, whether there are any vibrations, if the pressure is right, basically all the multi-physics simulation, if you like. So once we've designed our machine within AIMSIM, we can then connect it to PLCSim Advanced, and we can start testing the machine on the component level. But then the one next to it is Mechatronics Concept Designer, or NXMCD as we know it. So Mechatronics Concept Designer is to make sure your machine is the way you want it to test the sequence codes, to make sure there are no collisions, sensors are placed correctly, and basically the machine design is correct. So we can again connect Mechatronics Concept Designer to PLCSim Advanced and to SIMIT, and we can have a complete end-to-end virtual commissioning. Going one step further then is Process Simulate, Technomatics Process Simulate, if you like. So once we have designed our machine on this level, we can now start to bring some robots together and have a complete cell. So 2 or 3 robots working with the machine. So Process Simulate allows you to test the robot code. We can also write the code within Process Simulate itself. So we don't necessarily have to have the robot controller to write the code. We can do everything in Process Simulate, test the code for robots vendors like KUKA, Stoply, ABB, and we can start testing against our main automation main controller, and we can make sure the sequence is followed correctly. Process Simulate also gives us the cycle time of your cell. And then going one level up, which is our highest level of commissioning, is plant simulation. So we can design the plant layout in that. We can make sure how many cells we need, if the cycle time is perfect, if the material flow is the way we want it to be, and then scheduling, routing, etc. So for instance, if you have loads of AGVs, you can figure out how many AGVs you would need to have the complete plant working the way you want it to. And then you can also test the AGV's connection with the master controller and how it talks to the actual master code. So this is basically an overview of our complete portfolio. These are the 4 virtual commissioning solutions as we saw now. And in this session, we would mainly be focusing on virtual commissioning for machines, which is on this level alongside PLCSim Advanced and SIMIT. So we offer as a product Simatic Machine Simulator, which brings together SIMIT and PLCSim Advanced as in a bundle. And that combined with NXMCD creates a complete digital twin for us. So traditionally, any machine would have 3 components, the mechanical component as the machine itself. So NXMCD is used to design that mechanical component. Then they would have all the peripheral devices. So like I said, the drives, motors, and all that sort of stuff, push buttons. All of that can be simulated in SIMIT, and then we can write the code in PLCSim Advanced. And they are all connected, seamlessly integrated with each other to start testing. Now we can either have a software in loop, which means all of them, everything is in the software level, in the virtual level, and we don't have any hardware connection. But we can also have hardware in loop where SIMIT allows us to talk to the field devices like other controllers or other drives, for instance. And we can also connect actual HMI panels to PLCSim Advanced via S7 connection. Okay, so creating the digital twin, step 1, as I said earlier, first creating your NX model. So it looks something like that. You start seeing some graphics, some things moving around. So we basically create to the model, we give some physics and kinematics. So when I say physics, I mean you create a rigid body, you give it some mass, it falls under gravity, it reacts to frictions and all of that. So this is basically enriching your model with some kinematics. And we can start testing with different alternatives, so we can have different prototypes, with the idea being that we don't need any physical prototype, we just have virtual prototypes, and the first machine we make is the final machine which is being tested for everything. On this note now, I will quickly switch to show you how NXMCD actually looks like. Okay. So this is how it actually looks like. We have this machine here right now with not much physics to it, but we can start giving certain physics and it starts appearing on the left-hand side here. The certain things like runtime inspector, where we can start, during simulation, we can see the live values, say the speed or the mass or the position of your objects. There is an assembly navigator that tells you what are the parts and what's your assembly made up of. And there's also something called reuse libraries. So once you've made your kinematic model, you've given it certain physics, you can save it, and then you can reuse it for some other machines later on. So then that saves effort and time. On the top ribbon bar, we see loads of icons. So these basically allow you to enrich your model with kinematics. So we can make rigid bodies, we can make object sources, we can make certain collision bodies, transport surfaces, we can define the collision material. So we can define some specific materials of different frictions, for instance. We can define loads of joints, hinge joints, sliding joints, some sort of virtual joints if we like. And we can also have gears, couplers. We can design electronic and mechanical cams. So we can design the cams here. We can generate profiles, which can then be exported to a TIA portal to start coding inside TIA portal. We have some runtime behaviors and parameters, so we can write some background script that run during the simulation. So there are loads of options available here. We can create different kinds of sensors, so collision sensors, distance sensors, or any limit switches if you like. So you can create loads of sensors in your design in your machine. And we can have different controls, so position, speed controls, hydraulic valves if you like, pneumatic valves, etc. Okay, so right now in my model, nothing is happening because I haven't given any physics to anything. So I can quickly just create a rigid body here, and we can define some center of mass, some center of coordinate system, some mass and inertia values if you like, or it can be automatic. So if I play this, it just falls down because there's nothing stopping it, or it doesn't find any body that it can collide to. And to rectify that, we can make collision bodies. So I make that as a collision body, and now it sits on that. I can create certain transport surfaces, as I said earlier. So I can create transport surfaces. I can define what direction you're moving in. So it's this direction, and I can give it some velocity here. So once I do that, it starts moving and starts moving there as well. Okay, so just to quickly show about the transport surfaces, we see here there's a velocity that can be given. Now it can be either hard-coded, but in the real world there would be a drive controlling the motor for this conveyor. And that's what we aim to achieve. So this velocity can be overwritten by a command coming from PLC via SIMIT. So SIMIT does the simulation of drives, but the command comes from the controller, PLCSim Advanced. So we can then control the speed, we can control the positions, and we can control the complete movement of the belts. Okay, so that was just basic about Mechatronics Concept Designer. I forgot to mention that Mechatronics Concept Designer is basically an add-on to our CAD software called NX. So you could buy NX standalone, but MCD also you can buy standalone, but it comes as an add-on to NX. There's also an option to have inverse kinematics. So if you want to simulate some 6-axis robots, you can have import the CAD drawings from step file or Inventor anywhere, JT files if you like, and you can start giving some inverse kinematics to it. So you can define paths in how the robot arms are moving. This is the possibility with newer versions of MCD. And on the support side, Siemens support side, just quickly show you. We have, if you go on Siemens support industry, so support.industry.siemens.com, you can insert, you can look for NX MCD virtual commissioning toolbox. Once you do that, you would find loads of material here, which you can download. So it's a reusable library for kinematics toolbox. And it has a pre-prepared designs, models for different sorts of robots, so Cartesian portals or 4-axis or 3-axis, roller picker or SCARA arms if you like. And all the physics and everything is a part of this. So all we need to do is download the library, open it in MCD and just drag and drop, and it comes with all the physics. And then later on we can connect it to the virtual robot controllers or a TIA portal or any of the simulation softwares to start testing. Okay, so going back to my presentation then, the next bit obviously now is SIMIT. So we will have a look at it, which is, as I said, for the simulation of peripheral devices. So sensors, actuators, drives, temperatures, pressures, or hydraulics, we can do all of that. SIMIT allows, as I said earlier, hardware in loop and software in loop testing. So if we have software in loop, we have different couplings, which I will show in a bit, and we can all have it sitting in one machine. But we can also connect to the field devices using SIMIT unit. SIMIT unit is a hardware, it's like a switch, and through this you can connect to the Profinet and Profibus devices. So let's have a look at SIMIT now. And this is what SIMIT looks like. Again, similar to TIA portal, if people have worked with that before, the entire project tree comes on the left-hand side, and we can create different charts, which then start appearing here. There are loads of libraries available within SIMIT for simulation of different things. So I'll quickly take you through the libraries here. So the 7 standard libraries that come with SIMIT, some of them are paid, some of them are part of basic SIMIT. So for instance, we can see there's a library for drives. There are library for motors and then some Profi drive components. So I can drag and drop these blocks here. And then these basically come with some little faceplates, so they can see, you can see the status words coming from a PLC, some control words coming from PLC, and you can see all of that live values when you connect to TIA portal. And similarly, we have loads of other blocks that we can drag and drop, start connecting to different inputs and outputs, and these blocks behave as how an actual drive would behave. So there are some other libraries, for instance, for sensors, we have some RFID components that we can simulate, some counters, some load cell components, if you like. And then we have an extensive library for pumps, valves, separators, heat exchangers, some graphics as well. And these are all part of standard libraries. And then some standard components like for maths, addition, division, some basic maths, some extended maths, if you like, multiplexers and comparators and stuff. So this is the basic libraries that come with SIMIT. We also have some other specific components or libraries that are now defined with virtual commissioning in mind. So again, if you go on our support industry side and if you search for SIMIT library in here, there are a few application examples with manuals and some downloadable materials. So you can see there's something called SIMIT control library. And if I open this, there are loads of different control icons that are available. So for emergency switches or key switches, light buttons, if you like. And there's a manual associated with them that you can download and you can see how to link it with your control, your automation code. Similarly, we have a library for drives, so different drive telegrams, telegram 81, 82, 750, how to connect them, what they mean. And there's a project that you can download to get started with and how to start connecting with different drive telegrams within your automation code. Besides that, there are there's a complete manual for SIMIT, which is a must read if you are interested in working with SIMIT as a software solution. And there's also an RFID behavior library for the new RFID components. So this site is one of the good sites where you can go and look for different stuff or material, and you can download it, most of them free of cost. And there is something called a hardware exporter, config exporter. I'll get to it in a bit. So this was all about the libraries within SIMIT. Now the second thing is the couplings. Couplings is how SIMIT allows you to connect to other software. So when I say it connects to MCD or it connects to your TIA portal project or it connects to the hardware, it actually does that via this interface. Now there are certain predefined interfaces, but users can also create their own interfaces. It's easy to create the interface. So what we have right now, we have a coupling with SIMIT Unit. We have a coupling with PLCSim Advanced. It's grayed out because I already have used that coupling. As a coupling with MCD, which is also grayed out because I already have it. But then you can also have couplings for OPC UA, OPC TA, and shared memory as well. And so all you have to do to create these couplings, you would click on create new coupling, you would link it to wherever your file is saved, and it brings in all the components and elements associated with the parameters. So if you remember in MCD, we created a rigid body or we created a transport surface. So all the parameters of speed, position, anything that is associated with that component, all of these are imported here as inputs and outputs that can then be used in the charts to do the signal mapping. Similarly, in PLCSim Advanced, we can link it to the file wherever your project sits, and it brings in all the IOs. in SIMIT. An important thing to notice here is it only brings the actual hardware IOs. So you won't be able to see the data blocks or memory bits, but actual hardware IOs will all be imported here within SIMIT. Once we've done that, we can then start creating charts by bringing stuff from the library here, or if you have some global components, if you've downloaded stuff from your from the support site, it all sits in here in global components, and you can start dragging and dropping. So we can see here now I have a chart. This complete block is for Profi Drive Telegram 5. So you can drag and drop different components to create a complete block. And you can give it certain parameters, as you can see in the bottom. So what's the reference speed and all that sort of stuff. And what it's doing now is I have some inputs coming from PLC being manipulated as a drive would manipulate it and send some feedback back to the PLC. But then I also have a speed set point that is being sent to my MCD conveyor or the arm of the SCARA robot. It reads back the actual speed as a feedback. It also reads back the actual position as a feedback. So if we think about how it works in the real life, we have a drive that gets some command from the PLC. So this drive gets certain commands from PLC. The drive sends the RPM to the motor, which the motor starts moving. So then you can connect as a feedback through encoder. You can see the actual position of the motor and feed it back to PLC, which is then fed back to the your controller. So this is a complete closed loop control where all the three elements are simulated in different software. Besides that, we can also have, as I showed earlier, some sensors in MCD. So there's some sensors say if the gripper is enabled or not, or if my conveyor sensors are enabled or not. All of these sensors can be fed back to the PLC as a sensor feedback. So this is an overview of SIMIT, and we can also simulate safety IOs now within SIMIT. So if you have safety IOs, that can also be simulated. Going back to my presentation, I talked about different couplings. Another coupling that we now have is with virtual robot controllers of different vendors. So we can connect now to KUKA Lite or ABB Studio or Universal Robots VRC. And there's a direct coupling available within SIMIT to connect to their VRCs. So we can immediately start testing the robot movements and the sequence of your controller. And we can connect to Stobly via OPC UA. And for the rest of them, the coupling is still coming up. So maybe in the next version of SIMIT, we would have couplings for all of them, all of the VRCs. And the third element now is PLCSim Advanced. So I mentioned briefly earlier, it's basically to emulate our 1500 controllers. And we can do the simulation of different functions, including communication. We can simulate the know-how protected blocks. We can simulate safety, and also has web server capability. We can also create our own test code, and via API we can actually connect to our controller and we can start testing the code. Now PLCSim Advanced supports multiple and distributed instances, which means that you can have up to 16 instances of PLC controllers running on your same machine, and then you can start testing communication as well. But if you want more than 16, you can have distributed instances, so you can have different machines running PLCSim Advanced and different instances. So I'll show you what PLCSim Advanced looks like. This is what PLCSim Advanced looks like. As you see on top, PLCSim and PLCSim Virtual Ethernet Adapter. So PLCSim is if you have everything software in loop sitting in one machine. So as I said, you can have up to 16 instances here. You can just need to give it a name, ABC, and you can start, and it starts the instance for you. And you can download to this instance. So we can have up to 16 here. We can switch to PLCSim Virtual Ethernet Adapter. What it does, it creates a virtual switch, and then you can, via that virtual switch, you can connect to an actual port on your computer, and then you can connect to different machines. So you can have connection with different instances. Okay, so now that we have seen how these three software come together to create digital twin, now is the time for live demo. So before I do that, what we're going to see now in the live demo, we have these 3 conveyors. All these 3 conveyors are controlled by my code, which is written in TIA portal. And based on the positions of the box, they activate different sensors. And these sensors then activate, turn the conveyors on or off. And we have 2 different sizes of the box. One is a short box, one is a taller box. So they pass through these sensors here, and depending on whether it's a short box or a taller box, the SCADA arm would do the pick and place motion. Once they come down this conveyor, there's a sorter arm. So again, depending on the size of the box, they are sorted either in this box or in this box. Okay, SIMIT then. So as we can see, we have 4 different drives for 4 different arms of the SCADA robot, and we have 3 conveyors, conveyor 1, 2, 3. When I start the simulation here, SIMIT would start NXMCD for me. It will also fire up PLCSim advanced instance for me. So you would see that right now nothing exists here, but in a bit our PLCSim advanced instance would become active. So we now have MCD running. It's in run, so we can see that. And we can also see the PLCSim advanced instance is now there. It's called SCADA. It depends. You can give the name within a SIMIT, and whatever name you give, it comes across like that. And it's all green now because the program has already been downloaded to it. So it's ready to go. It's happy to go. I will use a simulated HMI now to control my machine. And we can, at this point, I'd like to mention, instead of having a simulated HMI, you can also have an actual HMI connected to PLCSim Advanced through that virtual switch. So then you can start operator training, and you can have a look and feel of how your screens will look on the HMI, on the actual hardware HMI. In this example, I have used something called Semantic Robot Integrator application. So we will have other sessions in following weeks where we'll talk more about this application example. But what this application example basically does is it gives you an integration with different robots from different vendors. So I will show it to you in a bit here. So this is where you can find it. It's a Semantic Robot Integrator. And it comes with some standard application code running in TIA portal, which you can then change and manipulate to suit your requirement. Also comes with standard HMI faceplate. So you can see this is what matches what I have in my application example, exactly the same faceplate I'm using. And we can request the code from this site, and you would be able to get some application code for integration with KUKA or Denso or Stubbly, or some standard kinematics like SCADA arms or tripods, etc. Okay, so let's go back to our demo then. Here we go. Okay. So you can see I can go in the toolbox, and you see there are loads of robots now available, and I could have chosen from any of them. But right now, because I'm only using a SCADA arm, I only have that activated. So I can choose that. I can turn it on. Protected. So now I'm the operator. I can turn on, and now I see some Cartesian positions and axis positions. Now, just to mention again, all of this comes straight from the faceplate, so I didn't have to create any of these. I can go on now to start configuring, homing, jogging my robot around, and basically doing the configuration. So it's very interesting to see that I don't have the machine right now with me, but I've started to test my code. I've started to test if my robot is properly integrated with my controller or not. I can do the homing. Right, and then I can teach different paths. So this is also a part of the application code. I can move to those different paths. I can define certain positions, and I can also do a manual jog, which I will do now. So in the manual jog, I can define at what speed I want to move. So 85% of the maximum speed, for instance, and these are the different axes that I can move around. So if you see, and I can now move it around quickly. And all the actual position is fed back to me from my machine or from my MCD in this case. So I can choose a position. Maybe this is a position I want to save. I can go and say, teach the position. I can give it any name I like, and I can teach it. I can then go to the position list. I've got a few positions saved already. So let's move to a different position. And all of this, again, is just a part of the application code, so it's easy to move around. Now it moved to a separate position. Let's go back to the position we saved. And it's moving back to that position. So I'm happy now, and then this way I can create loads of points, and I can start creating certain paths. So using different points that we've created, we can now create different paths, and we can create a complete movement of the robot arm, if you like. Okay, so right now I was in the manual mode, moving all this around. Now we will go in the auto mode and see how our conveyors are behaving. So I will start bringing my boxes in, my short box and my tall box. I'll go in the auto mode, and as I do that, now my conveyors start moving forwards. Now my robot does the pick and place, and it threw that around because I didn't put it in the auto mode earlier. And you can see now it was expecting to see a tall box there, but it's not the tall box. So now it's all confused, and it's now saved there. So we can then integrate these errors can then be fixed in your code, and you can introduce some sort of checks that make sure that your conveyor doesn't move if something is already there, if something is off the conveyor. And we can then go about going auto or manual and moving the conveyors back and forth. We can also see the actual code. So you can see now that in my actual code, it's waiting here to pick the tall box. And what's the problem here? It says the certain conditions are not met right now. So that's why it's not moving forward. And then we can have some alarms linked to this, that if my robot takes more time, I can do all sorts of testings like that. Okay, so this is the basic demo for how all the three components come together and how you can start testing, and the actual power of virtual commissioning it can be seen here. Go back to my PowerPoint now. Okay then, a few more things to share with you. There is a compatibility tool available. This is where you can find it. So because, as you know, there are 3 different software that are working together, and different versions keep coming up, it's important to figure out what versions are compatible with what versions. So if you go to this compatibility tool and you select SIMIT, you can find out what the different compatibilities of different versions of NXMCD, SIMIT, and PLCSim Advanced. There are some SIMIT MCD application examples available on our support site again. So if I go on my support site, this is the link, and this is really a comprehensive comprehensive list of all the application examples. So you can see there's something called Getting Started. It comes with a nice manual and some step-by-step guidance of how you can start setting up things in all the 3 different software. You can also do the motor sizing with NXMCD, and this is an application example for that. Besides that, we have some high-end application examples. So for a multi-carrier system, there's a toolkit available to start designing that. We can do some safety testings and simulations. So there's another example for that, and a multi-belt control. Besides that, on this site, on this page, you can also find some SIMIT libraries and options. So I showed that to you earlier, but you can also find it here. A link to SIMIT control library and to the drives library, RFID, a hardware control exporter, a configuration exporter tool, and to the SIMIT simulation platform in general. Okay, and going back to my PowerPoint then. Right, so now if you are interested in testing this on your own, in these COVID-19 times now, Siemens is offering a cloud solution for virtual commissioning for machines and for virtual commissioning for production lines. So for virtual commissioning for machines, it's a 21 days free trial, and it comes with a virtual machine that has a TIA 15.1, SIMIT 10.1, and XMCD 1911, and PLCSim Advanced version 2 and Service Pack 1. But it also has the examples that I showed earlier, the support site examples, and some training materials. You can quickly start getting used to all these different examples without actually having to buy any software. Similarly, we have for virtual commissioning for production lines. So that offers a Technomatics Process Simulate version 15.1.1. This is valid for 30 days, but only the Technomatics. It also comes with TIA 15.1 and PLCSim Advanced, and that's for 21 days. So this here you can get some getting started examples again and a complete demo to test the final setup. So this is the overview of virtual commissioning for me. I would like to mention here, week commencing 5th of May, as Damien mentioned earlier, we would be having more in-depth sessions for SIMIT, for MCD, and also for the complete virtual commissioning. So if you're more interested to know about SIMIT in details, different libraries, and MCD, then please keep an eye out for those sessions as well. That's it for me. Thank you very much, and I'll take the questions now.